Okay, Dalton's law of partial pressures. Okay, this is a very simple law. Okay, this is the last one we are going to learn in this unit. Okay, so if I have a box, a container, a rigid container which has nitrogen gas in it. Okay, and suppose it has a pressure of 1.2 atm. And another container with the same volume which has carbon monoxide in it. Maybe suppose it has a pressure of 2.1 atm. It's an assumption, okay? And another one, same size, same volume. You should draw the same sized box, okay? And it has helium in it. And suppose it has a pressure of maybe 2.5 atm. Not atom, atm. Okay, so I have three different gases with three different pressure, but the containers are same volume. I'm gonna add all this into a different new container with the same volume. So now it has nitrogen in it, CO in it, helium. Three gases, all the gases are in this. What will be the total pressure of this container? What will be the pressure of the, what?
5.8.
You are just doing what?
Basic math.
You are doing basic math. Basically, you are adding partial pressure of the pressure of nitrogen plus pressure of carbon monoxide plus pressure of helium.
Yay, we're done with the last unit.
That is called the Dalton's law. Yes. So according to Dalton, the statement is like that. If you, okay, the total pressure of a mixture of non-reacting, they should not react, then the problem will be different. Non-reacting gases will be equal to the sum of their individual pressures. So individual pressures, the correct terminology is partial pressure. That's why we called Dalton's law of partial pressures. So if we have 5 gases, P total will be P1 plus, P2 plus, P3 plus, P4 plus, P5. It will continue based on how many gases you have. Remember, all the pressure, if you are adding, they must be in the same unit. You cannot add atm with the millimeter of mercury. Unit must be the same. Okay. Units must be the same. If it is different, you have to convert that. Okay. So this tiny half sheet is basically a review of what we learned in the first day. First one is the pressure conversion, and second one is the temperature conversion. Okay. And there are 3 Dalton's law questions. I will do one pressure conversion as a review. Then do one of this question. The rest of that you are finishing. Okay. Let's do the first one. So we know that these are the different units of pressure you are going to see. Okay. It says air pressure for a certain tire is 109 kPa. That means kilopascal. What is the pressure in atmosphere? ATM. So you are going to start the T chart with the given number always. And on your formula sheet or here it's given 101.3 kPa is 1 atm. That's it. So you are basically dividing this with this, and your answer is 1.08 atm. So those are the pressure conversion. We learned that in the first day. You had a practice, like multiple practice we did in class, okay? Now go to this page, which says Dalton's law of partial pressures questions. Okay, let's do the first question. That's easy, direct question. Read it. The pressure of mixture of nitrogen, we can just say it is P1, and this one may be P2. You can give any number, okay, that doesn't matter. P1, P2, P3, and is this. That is the total pressure, PT. So the question is asking, what is the partial pressure of oxygen? So we are going to look for P3 if the other two pressures are this and this. You can do mental math, or if you want an equation, write it. PT equal to P1 plus P2 plus P3. And if you want to find P3, which is PT minus P1 plus P2, which is 150. And check whether all the units are the same. I think so. So 150 minus 100 plus 24, okay, 100 kPa plus 24 kPa, and your answer is what? You can do mental math in that. 26 kPa. That is the partial pressure of. Is that easy? Yay. Okay, so but next question, see the next question. It has 1 in millimeter of mercury, 1 in torr, 1 in psi, 1 in kPa, and you have to find the pressure in what unit? ATM. So do the conversions. Just do the first one. 1525 millimeter of mercury. We know that 760 millimeter of mercury is 1 ATM. So that will be your P1. Second one, which is 955 torr, and we know that in 1 ATM there is 760 torr. So that will be your P2. Okay, have a good spring break. So 26.5 psi. Psi means the conversion factors given here, or it is in your formula sheet. PSI means pound per square inch. That is PSI. So PSI 14.7 PSI is 1 ATM. Then you will get P3. And there is one more, which is kPa. 325 kPa and 101.3 kPa is equal to 1 ATM. So you will get P4. So finding PT, you have to do what? You are adding all this value. That is your P4. Good? Okay.